Chapter 9, Number 20. Two blocks are free to slide along the frictionless wooden track ABC shown in Figure 920. The block of mass M1 equals 5 kilograms is released from A. Protruding from its front end is the north pole of a strong magnet, repelling the north pole of an identical magnet embedded in the back end of the block of mass M2 equals 10 kilograms, initially at rest. The two blocks never touch. Calculate the maximum height to which M1 rises after the elastic collision. To solve number 20, we'll first look at the givens. The mass of the first block is 5 kilograms. The mass of the second block is 10 kilograms. The initial velocity of the block is 0 meters per second, and the height is 5 meters. To solve number 20, we'll need to find the maximum height that M1 reaches after the elastic collision with M2. Redraw the diagram given with the problem. Label M1 and M2 and the height in meters. First, set the kinetic energy equal to the potential energy, or 1/2 M1 V1 squared equals mgh. We'll use this equation to find V1 of the M1 block. Plug in the mass, acceleration of gravity, and the height to find that the velocity of the first block is equal to 9.9 meters per second. To find V1 final, we'll multiply the V1 that we just found by M1 minus M2 over M1 plus M2. This will end up getting you negative 1/3 times 9.9 meters per second. V1 final equals negative 3.3 meters per second. M1 GH max equals 1/2 M1 V1 final squared. We will use this equation to find the maximum height. Solving for H max, we get V1 final squared over 2G. After plugging in the numbers, this comes out to be 0.556 meters. This is the H max. You've found the maximum height and solved problem number 20. Great job.